Hey, you guys, I hope everyone's doing well. This is the video I am making this week for August 16th through 20th. This week, you guys are working with decimals. We're going to add, subtract, multiply, and divide decimals. So I'm just going to start off with 3 warm-up problems for you. So I want you to pause the video. I want you to try these on your own and come back and let's see what your answers are. All right, did you guys try them by yourself? All right, I hope you did. So the first one, did you guys get 9? If you did, you are right. The second one isn't 3 plus 3 plus 3, is it? It's 3 times 3 times 3. That's an exponent. The big 3 is the base. This is the exponent, so that means to multiply this digit together this many times. So 3 times 3 is 9, 9 times 3 is 27. So I hope you got that one right. And then how many inches are in a yard? So first of all, we need to think how many inches are in a foot. So of course there's 12 inches in a foot. How many feet are in a yard? 3. So if there's 12 inches in a foot and we have 3 feet, our answer is 36 inches. Good for you if you got that right. All right, so first I want to review our place values. So every time we have a decimal, that separates our words that end with THS from the numbers that we're used to, numbers in the ones place, the tens place, the hundreds place, so on and so forth. So if I write this number down, you know that this is 765, right? But as soon as we put that decimal, that's when we start the tenths, hundredths, thousandths, 10,000ths, 100,000ths, so on and so forth. So if I wrote down this number, I would say 765 and, when I see a decimal, I say and 700ths because the 7 is in the hundredths place. So when you're talking about decimals, one of these words is the last word that you say when you're pronouncing words correctly. 765 and 700ths. So what if I wrote this? Well, I say and when I see a decimal, the 5 is in the thousandths place. So I would say 86 and 135 thousandths, right? All right, so let's look at this number right here. First question is, what place is the 7 in? So the 7 is in the ones place. What about the 6 right here? What do you think? That's the hundredths. What about the 0? That 0 is in the tenths. And how do we say this number? So we say this number 4,387 and 62 what? Thousandths. 4,387 and 62 thousandths. What about this big number, right? So just for a second, pretend that none of this was here. Pretend. How would we say this number if the decimal was sitting behind the 1? We would say this number 5,221. Well, when we get to this part of the number, we're still going to say 5,221, but the last thing out of our mouths is the place value of this 1. So the 1 is in the tenths, hundredths, thousandths, 10,000ths. So when we say this, the last thing out of our mouths is 10,000ths. All right, so let me get rid of this that I marked out. All right, here we go. You practice it and then see if you're right. We would say this number 23,417 and 5,221 10,000ths. All right, raise your hand if you got it right. I hope that's all of you. All right, moving on. So when you add and subtract decimals, there's a few rules that we have to think of. You're going to line those decimals up right on top of each other. Then, if necessary, you're going to place in some zeros if they're missing, and I'll show you that in a minute. You're going to add and subtract like normal, including borrowing, and then you're going to bring your decimal straight down. So let's look at number 1. We're going to line up our decimals on top of each other. So I'm going to write 23.45, or of course 23 and 45 hundredths, minus, we're going to line up that decimal right there. So that 2 goes under the 4, the 13 goes over under the 23, and then there's a number missing. So I'm going to fill in a 0, and now I'm going to subtract as normal. So 5 minus 0, 4 minus 2, 3 minus 3, 2 minus 1, and look at number 4, bring the decimal straight down. So my answer is 10 and 25 hundredths. All right, let's try number 2. We're going to line up our decimals right on top of each other. So 0.269. That decimal lines up with this decimal right there. So my 44 goes here, my 9 goes here. Now let's fill in zeros. You don't have to fill them in up here, but it doesn't matter, it doesn't hurt. So now we're just adding like we always do. 9 plus 0, 6 plus 0, 9 plus 2 is 11. Bring down that decimal straight down, carry the 1. 4 plus 1 is 5. And there we go. And I've already brought my decimal straight down. So 45 and 169 thousandths. All right, so you guys try 3 and 4. I want you to pause the video. I want you to come back and see if your answer was correct. All right, so now I'm going to solve it. Hopefully you already know what the answer is because you paused the video and you tried them for yourselves. All right, now especially when you're subtracting, step number 2 is very important, okay? If you don't put a 0 here, a lot of people think, oh, okay, well, I just bring down the 3. Well, that's not correct. When you add a 0, can you take 3 from 0? No. So if adding that 0, or make sure you remember that you have to make that 0 a 10 and borrow from the 5. Okay, so that number 2 step, especially when you're subtracting, is very important. So we're going to now subtract 3 from 10, 4 from 6. We can't do that, so that's why I made this a 14, and I went ahead and borrowed and made that a 6. So 14 minus 6 is 8. We're bringing our decimal straight down. Rule number 4, bringing our decimal straight down. And then 6 minus 2 is 4. All right, so hopefully you got that right. Number 4. When you subtract, first of all, hopefully you already realized the word difference for math means to subtract. And make sure you subtract in the order these numbers right here are written in the problem. So you can't change those order. You can't change the order around or you'll get the wrong answer. So we're going to write 63.92 minus, line up our decimals, 4.218. I'm missing something right here. I must put a 0 there, and that will remind me to borrow. All right, 10 minus 8 is 2. 1 minus 1 is 0. 9 minus 2 is 7. Going to bring my decimal straight down. 6 minus 4 is 2. And 3 minus nothing is 3. So there's our answer. I hope you guys got that right. All right. What about the next problem? So this one's a little different because it gives us part of the math problem and it gives us the full answer, right? So let's see how we're going to figure out what goes right here. So I would just start solving the problem. I would solve every part that is complete. So I know that 0 plus 9 is 0, so that's right. And then I know that 8 plus 7 is 15, and I would have to carry the 1, correct? So what do I have right now? 3 plus 1 is 4. What would I need to make this a 6? So 4 plus 2 is 6. And I didn't have to carry, so I know that this is right. Because if this ended up being a 16, instead of this being a 4, it'd be a 5, right? So I know that missing number is a 2. All right, can you guys try the next 2 on your own and let's see what you get? All right, I hope you tried it. So I'm going to go ahead and solve the every part that I can. So 0, if this was a 0, 0 plus 5 is 5. 9 plus 7 is 16. Carry the 1. 3 plus 1 is 4. What do I need? 4 plus what is 9? That's a 5. All right, let's look at the next problem. This is subtraction. So putting that 0 there is very important. So I'm going to have to borrow, make this a 3, right? So now 10 minus 3 is 7. I had to borrow. Can I subtract something from 3 and make it and get 5? Nope, can't do that, right? So I'm actually going to make this a 13 because nothing from 3 is 5. But now if I make that a 13, can I take something from 13 and it equal 5? As soon as I made that a 13, I had to change this to a 1. So 13 minus 8 is 5. And then 1 minus 0 is 0. So then if I add straight up from the bottom, 7 plus 3 is 10. 8 plus 5 is 13, plus 1 is 14. Carry the 1. 1 plus 1 is 2. So I know my answer is correct. All right, Jackie went to Walmart and she bought 2 pairs of jeans for $29.45 each. She also bought a shirt for $22.40. Jackie had a $100 bill. How much was her change? Well, the first thing I got to do after I read this carefully, I realized that she didn't just buy 1 pair of jeans for $29.45. She actually bought 2 pairs of jeans. Did you guys pick up on that? I bet you did. All right, so the first thing I'm going to do is I can add for $29.45 twice, or I can just multiply it by 2. So 5 times 2 is 10, carry the 1. 4 times 2 is 8, plus 1 is 9. 8 times 2 is, did I say 8? 9 times 2 is 18. 2 times 2 is 4, plus 1 is 5. And there are 2 numbers behind the decimal, so I have to make sure I have 2 numbers behind the decimal. So 2 pair of jeans is $58.90. Plus, Jackie bought a shirt for $22.40. So I'm going to add the shirt. Now we're assuming that these prices already have tax included because it doesn't tell us anything about a tax rate. So I'm going to add here 0, 13, 11, and 8. I'm going to bring that decimal straight down. So basically, Jackie spent $81.30. She had a $100 bill. I'm going to add those decimals because we're using money, right? We always have money all the way down to the penny, and we're subtracting. So we have to fill in any blanks with zeros. So 0 minus 0 is 0. I can't take 3 from 0, so I'm going to turn this to a 10. So 10 minus 3 is 7. 9 minus 1 is 8. I'm going to bring that decimal straight down. And this became a 9, so I had to borrow. That 1 goes away. So 1 minus 8, I'm sorry, 9 minus 8 is 1. So her change was $18.70. So it is $18.70 plus $81.30 equal $100. Yes, it does. All right. So that's adding and subtracting with decimals. So we're going to move on to the next section. So once again, I'm going to start you out with a warm up. So I want you guys to pause the video and try those, and then come back and check your answer. Twelve plus 5 is 17, 7, 8, 9. All right, I got 197 and 182 thousandths. Did you guys get 197 and 182 thousandths? So hopefully you did. Oh, you know what? I wrote the problem down wrong, you guys. Oh my goodness. How do I do that? So what should be 193.182? Did I make another mistake? I think that's right. All right, y'all let me know if I got it wrong or right. All right, now the next one says 52.3 minus 8.75. Did you guys fill in a 0 right there? Line up those decimals. 10 minus 5 is 5. I'm going to make this a 12. 12 minus 7 is 5. That would be an 11 minus 8. 8, 9, 10, 3. And then that would be a 4. Right? Did I get that one right? I think so. I do make mistakes, so y'all gonna have to help me sometimes. All right, I think that's right. And then number 3 is 5 times 3. And you know what? I realize now there was a number 4. I just realized that, but you have it on your paper. So number 3 is 15. So if 5 times 3 is 15, I wonder what 5 times 0.3 would be. Did you get 1.5? I bet you did. I bet you did. All right, so let me get rid of all that writing. Good for you if you got all that right. Good job. Oops. There we go. All right, now for our rules for multiplying with decimals, we're going to line up the last numbers. Whatever the numbers are farthest to the right, we're lining those up on top of each other. We're ignoring decimals and we're multiplying as usual. Then we're going to count the number of spaces to the right of the decimals. And then we're going to move the decimal to the same number of spaces to the left in the answer. What in the world does that mean? Well, I'm going to show you. But first, let's talk about the rules for division. Number 1, the divisor must never be a decimal. It must be a whole number. So you have to make it a whole number. If you move the decimal in the divisor to make it a whole number, you must also move the decimal in the dividend the same number of places. After moving the decimal and the dividend, shift the decimal up into your answer straight up. And don't stop dividing until you reach the decimal or go past the decimal. All right, what does that mean? Well, let's find out. All right, so number 1, we're going to start by multiplying. So my number 1 set under directions was to line up the last digits or the digits to the farthest right. So 3 is to the farthest right and 5 is to the farthest right. So I'm going to have those last numbers sitting right on top of each other. And in this situation, it does not matter that the decimals are not lined up. Okay. All right, so we're going to ignore the decimals. I mean, we know they're there, correct? But we're going to ignore them and we're going to multiply as we always do. So we're going to multiply 3 times 5, carry the 1. 3 times 1 is 5 plus 1 is 6. 5 times 4 is 20, carry the 2. 5 times 2 is 10 plus 2 is 12. All right, we're going to multiply by the 1. So we're going to start with 1, 0, because we're moving to the 1 and there's a number in front of it. So 1 times 2413 is 2413. All right, now we're moving out to the third number. So we're going to add 2 zeros. Now 2 times 3 is 6, 2 times 1 is 2, 2 times 4 is 8, and 2 times 2 is 4. Bringing everything straight down. So we have 5, 9, 7, 4, 5, 6, 7, 8, 8, 9, 10, 11, 5, right? Now, those are our digits, but our answer is not finished yet because we don't know where the decimal goes until we count how many numbers are to the right of the decimal in the problem. I have 1, 2, 3. That means that we have to have 3 numbers to the right of the decimal in the answer. 1, 2, 3. So our answer is 518 and 795 thousandths. All right, let's look at number 2. We have 3.02 times 4.7. We're going to line up those last digits. 7 times 2, 7 times 0 plus 1, 7 times 3. Hope you guys are trying this. Pause the video, try these on your own before you check your answer. And then let me know if I get one wrong too. All right, how many digits are to the right of the decimal? 1, 2, 3. So 1, 2, 3. Our answer is 14 and 194 thousandths. What do you guys think? These take up a lot of room, don't they? When we're doing long multiplication. All right, number 3. Go ahead and try 3 and 4 and then come back and check your answers. So number 3, our last numbers to the right are the 2 and the 5. So they're right on top of each other. So 5 times 2, 5 times 3 plus 1, 8 times 5 plus 1 is 41. We're moving to the 3, so we got to add a 0. 3 times 2, 3 times 3, 8 times 8 times 3. And then we're going to add 0, 12, 11, 9, 2. How many numbers do we have behind the decimal? I didn't mean to make it always 3, but it seems like it's always 3. So 1, 2, 3, and I got 29 and 120 thousandths, or you could even say 1200ths. Same thing, because that 0 doesn't add or subtract from our value. And then number 4, we're going to, 3.81 times 0.6. 6 times 1, 8 times 6 is 48. So 18 plus 4 is 22. Once again, I have 1, 2, 3 numbers, 1, 2, 3. It's not always 3, but I wasn't thinking when I wrote the questions that all of these were going to have 3 numbers behind the decimal. So hopefully you got that. Everybody gets that answer. All right, number 5 says Jeff bought 6 apples. They are 45 cents each. How much did Jeff pay in total? Well, he bought 6 apples. The price was 45 cents times 6. So 5 times 6. 6 times 4 is 24, plus 3 is 27. How many numbers behind the decimal? 1, 2, 1, 2. So how much did those 6 apples cost Jeff? Cost him $2.70. Man, I wish I had an apple. Would be good right now. Oh, here's a little harder one, right? This is multiplication. But we know how to multiply 3 times 7. 3 times 7 is 21. Carry the 2. 7 times 5 is 35, plus 2 is 37. 7 times 0 plus 3 is 3. Then we're going to go to the 6, so we're going to add a 0. 6 times 3 is 18. Carry the 1. Whoops, that was a 1. 6 times 3 is 18. Carry the 1. 6 times 5 is 30, plus 1 is 31, right? And then carry the 3, and that's correct. So both of our missing numbers were 1. So that wasn't very hard, was it? We were just multiplying, that's it. All right, now we're going to talk about the rules for division. So when you divide, you always need to draw like the little division house, and the first number, when it's written this way, that first number always goes in the box. If I could read numbers better, you guys, I'd be a better math teacher. That's not a 2, that's a 5. So we're going to do 56.25 divided by the second number is 2.5. Well, the directions said this number right here outside the box must be a whole number. So we have to move. To make this 2.5 a whole number, we have to move our decimal to the right, which technically we're multiplying by 100. So now it's 25. However many places you move this decimal, you must move the inside decimal. So we're moving it right there. So we moved both of those decimals. So now we just have 25, and this is now 562.5. All right. So now we're ready to divide. How many quarters is in 56 cents? Well, we have 2, right? And that's 50 cents. So dividing by 25 is easy because we all know about money. So what about if I bring down my 6 and my 2, how many quarters would go into 62 cents? Well, it's still just 2 because 3 quarters is 75 cents. So that's going to be 50 again. So now we have a remainder of 12. And then we're going to bring that 5 straight down. And how many quarters makes up $1.25? That would be exactly 5. 5 quarters makes $1.25. And then we have a remainder of 0. And so part of our directions was we bring that decimal straight up. So 56.25 divided by 2.5 is 22.5. All right. All right, let's look at number 2. That first number goes in the box, 17.2 divided by 6. Well, this number outside the division box is already a whole number, so we don't have to move anything. It doesn't matter that there's a decimal inside. That's totally fine. We just got to make sure this number is a whole number. It already is, so we're not changing anything. Well, I know that 6 times 3 is 18, so 3 is too big, so we're going to use a 2. We're going to subtract, and we get 5. Bring down the 2. How many times will 6 go into 52? Well, 6 times 8 is 48. So I think that's as close as we're going to get, right? 6 times 8 is 48. So we subtract, that becomes a 12. 12 minus 8 is 4. 0. All right. Well, I have a remainder, so that means I'm going to add a 0. I'm going to bring it down. How many times will 6 go into 40? Well, 6 times 6 is 36. We got a remainder of 4 again. So guess what? We could do this all day long, and we're going to have a repeating 6, right? So this would go on and on and on, right? So the way to show that a number repeats forever is to put a line over it. So that is the answer for number 2. How you guys doing? Are you getting these right? All right, let's do 3 and 4, and then I think 5 and 6 are it. I was just double checking. All right. So number 3, this looks like a fraction, but really that fraction bar is always just a division bar. Really, that's what it is. So we're going to put 6.58 divided by 0.9, 0.9. We're going to move this once, so we got to move this once. So now what we're really dividing is 9 into 65.8. So 9 won't go into 6, but it'll go into 65. Let's see, 7 times, right? Let's see, 7 times, yes. 7 times 9 is 63. So then we subtract and get 28. Well, 9 will go into 28 3 times, and that's 27. And then we get a remainder of a 1. We're going to bring that decimal straight up. Very, very, very important. And then when we bring down that 0, 9 will go into 10 once. And we're going to keep getting a remainder of 1 forever and ever and ever. So that 1 is going to repeat. So we're going to have 7.31 repeating forever and ever and ever. Okay. All right. Number 4. That 0.4 goes in the box. Outside the box, we have 0.0018. How many places do we have to move that decimal to make that 18 a whole number? 1, 2, 3, 4. 1, 2, 3, 4. So really, our math problem is 18 into 4,000. So 18 into 40, let's see, how about twice? What do you think? I think twice is going to work. 2 times 8 is 16, carry the 1. 2 times 1 is 2, plus 1 is 3. So 40 minus 36 is with a remainder of 4. Uh-oh, guess what? All of these are going to be repeating again and again and again. 36. Remainder of 4, bring down a 0. We have to keep going until we get to that decimal at least, because that's where our decimal is now, right? We moved it over. So it's going to keep going on and on and on. So once we get to that decimal, now we can show repeating, but you can't leave these blank. You have to fill in all the digits up through the decimal at least. And then hopefully it'll terminate or it'll keep going in a pattern. All right, how you guys doing? Hope you're doing well. All right, try 5 and 6 and then check your answers. We're almost done. Pam has $595 of cookie dough money to turn into her coach for a fundraiser. She sold 17 tubs of cookie dough. How much did each tub cost? So she raised $595, and we're dividing it by 17 tubs. I'm not sure why this problem's in here. It doesn't have a decimal, but since it's money, we can think of it goes all the way to the penny, right? All right, so 17 goes into 59 about, I don't know, probably 3 times, don't you think? 3 times 7 is 21, carry the 2. 3 times 1 is 3, plus 2 is 5. Oh, that was close. All right, 9 minus 1 is 8. Bring down the 5. 17 into 85 would go about 5, maybe 5. 5 times 7 is 35, carry the 3. 5 times 1 is 5, plus 3 is 8. Oh, it was exactly 85. So we have a remainder of nothing. So we could say, how much did each tub cost? Well, since it's money, we could leave it as $35, or we can write money all the way down to the penny. So each tub was $35. Okay. All right, number 6, Johnny makes no, he doesn't. Johnny makes $8.25 per hour working at Domino's Pizza. Oh my goodness, I used to work at Domino's Pizza, you guys. Last week, his check was $268.95. How many hours did Johnny work last week? Well, we want to take his big check, which was $268, and divide it by how much he makes per hour. He makes $8.25. Do we have to move our decimal this time? Yep, 1, 2 places, and so here it's 2 places. So our decimal is sitting at the end, so I'm going to erase that. Okay. All right, come on, pen. So think about 825. Will it go into 2? No. 26? No. Will it even go into 268? Nope. But it'll go into 2,685 or 89 about. I know that 3 times 8 is 24. I wonder if 3 is too large. Let's find out. 3 times 5 is 15. Carry the 1. 3 times 2 is 6, plus 1 is 7. And then 3 times 8 is 24. So I think we got as close as we could. 9 minus 5 is 4. 8 minus 7 is 1. 6 minus 4 is 2. All right, now we get to bring down our 5. So 8 will go into 21 about 2 times, right? So remember our decimal's right here. So we need a number here. So 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. And 2 times 8 is 16. So I have a remainder of 5, 9, because that's a 14. This is a 10. And so that'll be a 4. So then, since I don't have a 0, I get to add, since I have a remainder, I have to bring down a 0. I'm going to bring that decimal straight up, bring down that 0 right there. So 8 will go into 45 about, well, 6 times 8 is 49. I'm wondering if 6 is going to work. Let's try 6. So 6 times 5 is 30, carry the 3. 6 times 2 is 12, plus 5 is 15. Carry the 1, and then 6 times 8 is 48, plus 1 is 49, and now I have a remainder of 0. So how many hours did Johnny work last week? He worked 32.6 hours. 32.6 hours, okay? And that would be 0.6 hours. That's not 60 minutes, obviously. That's the whole hour. It's 6/10 of an hour. All right, so I hope that helped you guys as you work through the lessons this week. So that's what you're doing. You're adding, subtracting, multiplying, and dividing decimals all week. If you need me, if you have any questions, let me know. And I will be happy to help you guys. And I look forward to communicating with you. Everyone have a great week.